Now we are going to understand what are the ways to represent a molecule in three-dimensional. So one is dash and wedge structure. So how we will be representing a 3D structure is I can represent something like that. So if I take three groups, so what is here? See, this something like this will be mostly shaded. So something like this means this bond is towards the observer. This is towards observer. And this bond where you see dash means in the back side. That means away from observer. If I'm writing it on the board, that means this bond is behind the board. And this bond is towards me, towards you who is watching this, right? Away from observer. Next, these two bonds are in the plane of board, in the plane, as if these two bonds are in the plane of the board, right? So if you have the solid bond, that means this is towards the observer, and this dash bond means behind the or away from the observer, behind the plane, right? And these two dash bond means they are in the plane of the board. Now there is another method. This was dash and wedge. Now I'll be explaining Fisher projection. Fisher projection. So how is that? Let's see. In Fisher projection, we take just like this. We represent the groups. This is the central carbon which is not represented at all. We have to imagine it is a central carbon, or and the groups are attached something like this: CHO, OH, CH2OH, and H. So you have to visualize that the horizontal bonds are towards you. The horizontal bonds are towards you. These are solid bonds. These are solid bonds. And the vertical bonds are away from observer. You have to visualize like this. All right. But in reality, we will be representing the Fisher projection without these dash, right? So dash and solid will not be there. You have to understand that vertical bond is dash bond, and horizontal bonds are towards the observer. Horizontal bonds towards observer, towards me, and dash bonds are away. That means vertical bond is always behind the plane, and the horizontal bonds are towards the observer. So that is what you have to make out whenever you see Fisher projection. Fisher projection is something like this. You have groups written like this. So this is Fisher projection where vertical means away from observer, and the horizontal bonds means towards the observer, right? So I have explained Fisher projection and dash and wedge. And sawhorse is a representation for conformers. So if I write like this, that means if I write like this, that means simply that one carbon is present here and one carbon is present here over here, and this is the oblique line which connects carbon to carbon, right? So this is very simple representation, and you can make out from the given structure. Now Newman projection is another representation for conformers. Here what we do is, for example, I have ethane and I have to draw the Newman projection for this. Ethane is CH3CH3. Now there are two carbons. Alright, there are two carbons. If I take like this, so there will be a front carbon and there will be a carbon at the back sides. No, now the front carbon will be represented with a dot and the back carbon will be represented with a circle. So CH3CH3, I'll write it like this. Front carbon, if I take it this front carbon, is front, and this is back carbon. So how the structure goes, the structure is written dot means front carbon, right? So this carbon has 3 hydrogen bonds. So I will write like this at H, H and H. Now the back carbon will be represented with a circle, and all the bonds attached to this back carbon are represented on this. So hydrogen, hydrogen and hydrogen. So this is Newman projection where circle represents back carbon and this dot represents front carbon. This dot represents this front carbon, right? So that is how Newman projection is represented. When there is a overlap, there is eclipse form. When there is no overlap, something like this. This eclipse form, this eclipsed, this eclipse form. When the bonds on front carbon and back carbon are overlapping, this is called eclipse. And when they are exactly on opposite sides, then this is known as staggered. In ethane, staggered has conformer has a torsional angle of 60 degree. That is also known as dihedral angle. So 60 degree is the dihedral angle over here. Torsional strain is very less, and in this torsional strain is very high. So this is unstable and staggered is stable. You have to remember the dihedral angle. Sometimes in questions you will find they are asking for dihedral angle. So that is it for now. Thank you.